In a striking revelation that has sent ripples through the scientific community, NASA has unveiled evidence of a celestial body emitting mysterious, seemingly artificial light. This unprecedented observation points to a world unlike any we've seen before, a dwarf planet in the asteroid belt that not only harbors unexpected geological activity but might also hint at the potential for extraterrestrial conditions. Could this dazzling glow be a natural phenomenon, or does it mark a clue to something more extraordinary? Are we perhaps standing at the edge of a discovery that could change the way we view our place in the cosmos? This astonishing chapter begins with the Dawn spacecraft, launched by NASA in 2007 with an ambitious mission to explore the two largest objects in the asteroid belt between Mars and Jupiter, Vesta and Ceres. What made Dawn unique was its use of ion propulsion, a highly efficient form of thrust that allowed it to change orbits and visit multiple celestial bodies, something traditional chemical rockets couldn't do. This groundbreaking technology propelled Dawn on a 7.5-year journey, where it would conduct close-up investigations of worlds never before seen in such detail. The first stop was Vesta, the second most massive body in the asteroid belt. Dawn spent 14 months orbiting and mapping its surface, revealing towering cliffs, vast impact basins, and remnants of ancient geological processes. Once Vesta's secrets had been uncovered, Dawn initiated the most compelling leg of its mission, a transfer to Ceres, the largest dwarf planet within the asteroid belt. Ceres, discovered in 1801 by Italian astronomer Giuseppe Piazzi, was the very first object found in the asteroid belt and was originally classified as a planet before being demoted to an asteroid. Then in 2006, it was reclassified again as a dwarf planet, placing it in the same category as Pluto. With a diameter of approximately 950 kilometers, Ceres is massive enough to be rounded by its own gravity and possesses a complex internal structure, features that make it a subject of intense scientific curiosity. What truly transformed Ceres from a curiosity into a scientific sensation, however, was the appearance of bright, reflective spots observed on its surface, particularly in a massive impact basin known as a crater. These glowing features were spotted as Dawn approached in early 2015, and they immediately sparked widespread speculation. Early theories proposed that the lights could be ice patches reflecting sunlight, salt deposits, or even signs of cryovolcanic activity, geological processes that expel liquids like water or brine instead of molten rock. When Dawn began transmitting detailed images of Ceres' surface, the mystery deepened. These spots were not isolated, they appeared in clusters and varied in brightness, some pulsating over time. The most famous of these, spot 5 inches inside a crater, consisted of several discrete bright areas that formed a pattern unlike anything observed on similar bodies. The prevailing theory suggests these are sodium carbonate deposits, a type of salt likely left behind after briny water erupted from beneath the surface and quickly sublimated into space. The result is a highly reflective material that stands out against Ceres' otherwise dark, rocky crust. This phenomenon, cryovolcanism, is rare in the solar system. It occurs when liquid water, mixed with substances like ammonia or salt, erupts from below the surface in extremely cold environments. On Earth, volcanic eruptions involve molten rock, but on icy worlds like Ceres, it's water and chemicals that spew forth. When this salty water reaches the surface and is exposed to the vacuum of space, it instantly transitions from a liquid to a gas, a process known as sublimation, leaving behind glistening salt crystals. The presence of cryovolcanism and salty residues suggests that Ceres is not just geologically active, it may also harbor subsurface reservoirs of water or brine. This raises one of the most compelling questions in planetary science. Could Ceres host the conditions necessary for life? What sets Ceres apart from other asteroid belt bodies is its composition. Unlike typical asteroids, which are primarily rocky or metallic, Ceres contains large amounts of water ice, hydrated minerals, carbonates, and even ammonia-rich clays. These materials point to a formation farther out in the solar system, perhaps beyond the orbit of Neptune, followed by a gradual migration inward to its current position. Such a journey could explain the unusual chemical composition of its crust and mantle. Internally, scientists believe Ceres has a layered structure, an icy crust, a briny or muddy mantle, and possibly a silicate-rich core. This structure implies that the dwarf planet once had, or still has, enough internal heat, likely from radioactive decay, to keep some water in a liquid or semi-liquid state. The implications are profound. If even a small celestial body like Ceres can retain heat and water for billions of years, the number of potentially habitable environments in the solar system may be far greater than previously believed. The bright spots scattered across Ceres' surface aren't all the same. Some are intensely reflective and associated with younger craters, while others are fainter and located in older, eroded regions. This variety suggests a long history of internal activity, possibly fueled by cycles of heating and cooling beneath the surface. The concentration of spots in certain regions also points to regional geological processes, possibly linked to buried brine reservoirs or structural weaknesses in the crust. Dawn's observations went beyond just spotting surface features. Its instruments analyzed the light reflected off Ceres' surface to determine its mineral composition, revealing significant quantities of carbonates, ammonia, and clays, materials associated with liquid water and hydrothermal processes. These findings not only confirmed that water once played a major role in shaping Ceres, but also that some of that water might still be present today, just beneath the surface. Adding further intrigue is the detection of transient water vapor plumes. Although not as dramatic as those observed on moons like Europa or Enceladus, some scientists believe that localized sublimation events on Ceres could be producing thin plumes of vapor that briefly escape into space. While this remains unconfirmed, it strengthens the idea that the dwarf planet is not a static world but one that continues to evolve. Beyond the scientific data, the discovery of Ceres' bright spots and potential water activity ignites the imagination. If life can emerge in the deep oceans of Earth, protected by ice and fed by chemical energy rather than sunlight, then perhaps similar processes could exist on Ceres. Microbial life, if ever present there, would likely lie below the surface, hidden from radiation, nestled within briny pockets where warmth and chemistry intersect. As we look beyond Earth for signs of life, Ceres joins a growing list of candidate worlds. Moons like Titan, Europa, and Enceladus have long been considered top contenders, but Ceres, with its accessible location and active geology, presents an attractive destination for future missions. A lander or drill-equipped rover could one day sample the bright spots directly, searching for biosignatures or chemical markers of past life. Meanwhile, the legacy of the Dawn mission continues to shape our understanding of the solar system. From its innovative use of ion propulsion to its transformative observations, Dawn has expanded the boundaries of what we believed small planetary bodies were capable of. It showed us that even dwarf planets, once considered mere debris, can be active, complex, and potentially habitable worlds. Ceres, once just a faint dot in the asteroid belt, is now a focal point of planetary science. It represents a bridge between rocky worlds and icy comets, a relic of the early solar system that still holds secrets waiting to be uncovered. As newer missions are developed and more sophisticated instruments become available, we may one day unravel the mysteries hidden beneath its surface. Could Ceres hide a subterranean ocean? Will future explorers discover signs of microbial life? Might we learn that these icy worlds are more common, and more alive, than we ever imagined? One thing is certain. Ceres has gone from an overlooked speck of rock to a symbol of possibility. Its story is still being written, and as we continue our journey to understand the universe, it reminds us that even the smallest worlds can hold the biggest secrets. For more mind-blowing discoveries like this one, don't forget to like, subscribe, and keep exploring with us here on Discovery at 2.0.